Assalamualaikum warahmatullahi wabarakatuh to Dr. Mariam Jamilah and Dr. Fahana. My name is Mohamad Naim bin Bakar. Today I will be present my final year project. The title is Crop Disease Detection on Vertical Farming using Image Processing. Okay, we jump to the objective. The first objective is to design a detection system for crop disease control in vertical farming using Arduino Uno and Educan 2 megapixel plus camera. Second objective is to develop image processing system for information extraction of powdery and downy disease by image recognition using MATLAB software. The third objective is to classify the type of disease by using multi-class support vector machine multi-SVN algorithm. Next is scope of study. First, Arduino Uno will be used as microcontroller to process and manage the input image. Second is Educan 2 megapixels used as camera to capture the input image. Third is MATLAB software used to process the image by using image processing toolbox. And lastly is choice sum will be the crop experimental crop. So this crop will be exposed to the powdery mildew disease and downy mildew disease. Next, methodology of the project. First, the disease image from the choice sum captured by the Educam camera, and then the camera is uploaded to the computer. The camera is controlled by the stepper motor to move horizontal left and right, and the stepper motor is output from the Arduino. The input control the stepper motor is joystick. So when we get the input image, we do the analysis input image by MATLAB image processing. So in the MATLAB image processing, we select the image, do the image processing until we get the feature extraction, and then the feature extraction will be input to the database to compare. Lastly, we will get the name of the disease. So this is a flowchart for the image processing. Here we can see there are two flowcharts that connect to each other: database training and disease detection testing. So the flowchart start with the image capture, image acquisition, image pre-processing, image segmentation, feature extraction, and then go to the image classification. Before that, the data from the feature extraction will be compared in the training data to obtain the name of disease, to obtain the image classification result. Lastly, we get the result, which is a name of disease, area of infection, and accuracy. So for image capturing system, we have a circuit diagram and final circuit diagram. So to capture the image, we have to attach the camera on the vertical farming. So the camera will attach at the slider above the plant. So stepper motor will be used to move the slider right and left horizontally. So joystick is analog input to control the motor rotation. So this is a prototype design and final design for the vertical farming. So the vertical farming occupied with camera on the top of the plant, LED panel for the plant grow, and controller box and stepper motor to move the camera horizontally. Next is image acquisition. So to capture the image from the vertical farming, we need Educan host application. So this application can be opened on the laptop. So we connect and we capture the image of the plant. So the image will be saved into the selected folder. For the image pre-processing, this step is to uh, adjust the color map and image intensity value. So the image will be more clearer and digit spot will be more focused. Okay, for the image color segmentation by K-means clustering, uh, we want to get the region of interest where only the area disease located. So the K-means clustering we divide the image into 3 clusters. Only one cluster will contain the disease spot or disease area. Next is feature extraction. For this project, there will be 13 feature extracted value from the cluster selected region of interest. So the feature extracted are from the statistical structure feature, rain level co-occurrence metric, color feature, and other feature. So the 13 features are contrast, coloration, energy, homogeneity, entropy, mean, variance, standard deviation, skewness, kurtosis, smoothness, RMS, inverse difference movement. Database training and image classification. For database training, we use multi-SVM. Support vector machine SVM is based on maximizing the minimum distance from the starting hyperlink to the nearest hyper. By using multi-SVM, the image database feature can be classified into a few classes in the database and can be used to predict incoming input text. In the classification step, the feature extracted from the image will be compared and tested to the database training to obtain its disease name and accuracy. Next is MATLAB graphic user interface for disease detection. In this GUI has 5 push button. First is insert image. So we select image for the from the local folder. Next is enhance contrast, and then segment image. We only select cluster that contain the disease area, and then classification result to obtain the name of disease, and lastly for the accuracy. On this GUI also we be provided the value of feature extracted and affected region. Next is subject test. So the subject test in this project is choisam plant. So this project required to grow the choisam in vertical farming to collect the data. First attempt to grow the choisam failed because not enough lighting. Second attempt also failed because the pH value in liquid fertilizer is too high, causing the choisam to die. Lastly, after discussion with SV, this project decided to buy the choisam from the local farm. So we have 4 We have four subject tests for plum of choice. Plum number 1 and 2 will be exposed to the powdery mildew disease. Plum number 3 and 4 will be exposed to the downy mildew disease. So the data will be collected for Friday in the row to see the changes on the leaf, whether it's affected to the disease or not. So this is result for the plant number 1. For the plant number 1, supposedly uh, to affected by powdery mildew disease, but it turns to the plant remain healthy. From day 1 to 5, the plant has no disease detected on the leaf. The result for the all image by the days are healthy leaf and no area infection calculated. So on the day 5, the accuracy value is 98. That means the accuracy increase uh, day by day. This is the result for plant number 2. This plant is unpredictable, had effect by downy mildew disease, but not powdery mildew disease as expected. A small brown spot spotted on the leaf on the day 2 and enlarged its area until day 5. The area affected on the day 2 is 15%. The area quickly grew by 25% on the next day. The accuracy, the input image for the day 2 to the day 5 uh, rise 3.2258%. Effect from the disease spot, the enlarged by 14% and its characteristic precise to the downy mildew disease. So for the plant number 3, at the day 1, the leaf already yellowish color in upper part and turn fully yellow color in day 3. The image processing system already recognize the chosen plant affected by downy disease from the day 1. At the day 4, the leaf shrink causes accuracy drop by 96% to the 92%, and the area of infection decreased by 11%. Okay, for the result, plant number 4. The plant number 4 affected by downy mildew disease on the day 1. The disease spot slightly turn to brown on the day 2. The area of infection in this case is less than 50%. The area of infection slowly decreased to the 11% as calculated on the brown spot area only. For accuracy, disease detection system obtain result accuracy above 95%. For the discussion, among the 4 plant, the plant number 1 is not affected by any disease, while other plant affected by the downy mildew disease. Plant number 1 and 2 fail to get the powdery mildew disease, while plant number 3 and 4 successfully exposed and affected by downy mildew disease. Among the 4 plants, plant number 4 only show the highest accuracy of downy mildew disease with 98% and area of infection by 11%. Plant number 1 show the highest accuracy of head leaf with 98%. Lastly, this project successfully built the GUI for the whole disease detection system. Conclusion. Conclusion. This project successfully in designing crop disease detection system on vertical farming by using Arduino Uno and Educam 2 megapixel plus camera. All features selected for the region of interest had done by using image processing technique in MATLAB software. The name of disease has been classified by multi-support vector machine method. The GUI graphic user interface development function to simplify the usage of disease detection project and more user-friendly. From the result, the system can be detect name of disease, uh, the area of infection, and the accuracy. Recommendation for future work. For the future work, uh, the project can be upgraded for database. Recommendation for future work. For the future work, work recommendation recommendation for future work. For future work, this project can be upgrade its database for better accuracy. Next is improve the resolution of camera so we can the image taken will be better in resolution. Lastly is recommendation for future work. This project can be can upgrade its database for the better accuracy. This project can improve in terms of camera resolution. Next is this project can be implemented to the Internet of Things and smartphone operating system OS. That's all. Thank you.